So this is the last subtopic of Unit 2. Well, not the last one technically, but this is the last subtopic that we haven't covered from Unit 2. We've already covered all the other topics on Unit 2. So we're just going to do derivatives of derivative of exponentials, and derivative of logarithms. It's pretty straightforward, guys. I could just tell you what it is, but I want you guys to know where it comes from. So we're just going to utilize this property here, and we're going to just try to get it to there. So we're going to do an informal proof here of what the derivative of e to the x is. So I'm going to write, so remember what we always do, f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. So if I tell you that f of x is equal to e to the x, then that means f of x plus h must equal e to the x plus h. Have I lost anyone? I haven't done anything. All I've done was identify what the function is and identify what f of x plus h is. So what are we doing? We're proving the derivative of e to the x. You guys ready? I'm going to go f prime equals limit as h approaches 0 of this guy, e to the x plus h minus e to the x all over h. I haven't done anything crazy. I'm going to use your law of exponents right here, guys. So if you have e to the x plus h, that's the same thing as saying, let's see, limit as h approaches 0, e to the x times e to the h minus e to the x all over h. So get to there. I notice I have a product here that has an e to the x. I have an e to the x there. I can factor out an e to the x. So limit as h approaches 0, factor out e to the x, parenthesis, you have e to the h minus 1 over h. And then all you got to do, check it out. Look at this guy right here. I can move this e to the x. It's unaffected. I can move it right there. E to the x, limit as h approaches 0, e to the h minus 1 over h. All this that I'm circling in purple is just 1. So I get e to the x times 1. So that means that my derivative is simply e to the x. It's the only one that's like that. It's the only one that the derivative is itself. Are we cool? So what does that mean? The derivative of e to the x is simply e to the x. If we do chain rule, here it is with chain rule, the derivative of e to the u is e to the u times du dx. Good thing we spent an extra week. Good thing we spent extra time with chain rule. So there it is. Cool or not cool? How do we feel? Nothing crazy, right? So there's our proof. So check it out. Go to the next page. We're going to do one problem together. And then we're going to see how it looked on the AP exam. And I think that year was 2008. So all this is the exponent. The x plus x squared. You don't have to do the proof over and over again. All we're going to do is just take the derivative. Just use the rules. So y prime, or dy dx, equals the derivative of e to anything is itself, as long as the anything is an expression in terms of x, right? If it was e squared, the derivative of e squared is just 0 because it's a constant. So dy dx equals itself, e to the x plus x squared. Am I done? No. Chain rule, that's why you see me open a parenthesis. What's the derivative of x? 1 plus the derivative of x squared? 2x. Done. Leave it alone. Cool or not cool? All right. There's always someone that's going to get tricked. If I tell you what's the derivative of e to the pi, what are you going to tell me? Are you going to tell me e to the pi? No. What are you going to tell me? Not everyone at the same time. What are you going to tell me? It's 1. It's a e to the pi. Is it a constant? What's the derivative of a constant? This is 0. If I tell you e to the x, the derivative of e to the x is e to the x, know the difference. That's an exponential function with the variable x as an exponent. This has a pi as an exponent. That's a constant. So the derivative of a constant is 0. The derivative of e to the x is e to the x. Are we cool? Okay. This is from, I want to say it's a 2008 AP exam. 65, let me tell you how to read this. 65% of the total population got it right. Out of the 5s, 89% of the 5s got it right, 79% of the 4s got it right, 69% of the 3s got it right, and then 57% of the 2s, and then 33% of the 1s. So, what's the difference between qualifying and not qualifying? I think the ones that are qualifying are getting these questions correct. Relax, you haven't had much practice. Do you guys want to give it a head start and see if you guys can figure this one out? All right, try it out, guys. Take a minute and a half. I just rewrote it. I haven't done anything yet. You make a note that 2 over x is the same thing as 2x to the negative 1. Here we go. F prime of x equals itself, e to the 2 over x, times the derivative of 2x to the negative 1. So negative 2x to the negative 2. Let's make it look like that. The negative 2 times e, so I'm going to write negative 2e, 2 over x. Bring that x to negative 2 down, x squared. I look for that. It looks like it is, it looks like the, yay or nay? How do we feel? Okay, so right now all we know is how to take the derivative of e to the x. We're about to learn how to take the derivative of another exponential. So relax, we're going to go slow. What if the base is not e? So we're going to do a hack. Here's the hack. Relax. A to the x, e to the ln of a to the x, that is still just a to the x. See, e and ln are inverses of each other. Side note, if you see e to the ln of 7, that's just 7. Power rule of logs, bring that exponent to the front. So this e to the x ln of a is the same thing as a to the x. So I'm going to go d dx, I haven't taken the derivative yet, of e to the x ln of a. Why am I doing that? Because I know how to take the derivative of e to the x. The derivative of e to the x is itself, e to the x ln of a, times the derivative of the exponent. Now I just have a linear term. It's just x ln a. ln a is a constant. So what's the derivative of x ln a? ln a is a constant. Remember, I have an x in the front. No. Okay, side note. What's the derivative of 3x? 3. What's the derivative of pi x? Pi. So what's the derivative of x ln a? ln a. Do you guys see what we did? Okay. All this that I'm circling right here, that's just a to the x. That's all it is. So a to the x, ln a, that's your answer. That's it, done. Cool or not cool? So, chain rule? Yes, ask.
Why is it just
Yeah, because this right here, e to the x ln a, if you rewrite it, bring the x over ln of a to the x. See, e and ln are inverses of each other, so that's just a to the x. All right, guys. So here it is, chain rule. Bless you. So the derivative of a to the u is itself times ln of whatever your base is times chain rule du dx. Cool or not cool? So we're going to go slow, real slow, guys. So here we go. Plus, we're going to review also a little bit here. At what point on the graph of the function y equals 2 to the power x minus 3 does a tangent line have a slope of 21? No calculator. If I want to know where I have a slope of 21, I need to take starts with letter D, derivative. So here we go, guys. This is an exponential function. Do not bring the x down. It's an exponential function. You have to use these rules. So y prime equals 2 to the power x times ln of 2. And then the derivative of 3 is 0, so leave it alone. And I want my slope to be 21. Is anyone confused with how I got that? Okay, tell me. My rules right here. d dx of 2 to the power x. This is telling me a is my 2. So it's telling me that it's itself, 2 to the x. And it says ln of a, so ln of 2. And then du dx, the derivative of x is just 1. So there it is, 2 to the x ln of 2. I'm just using my rules. Okay. Guys, ask me, guys. Okay. I'm trying to solve for x. What do I do first? I'm done with calculus. The rest is algebra. No, the calculus was just a derivative. Everything else is algebra, guys. I'm trying to solve for x. They want a point. Doesn't it say they want a point? How do I get x? What do I do first? Yes, divide both sides by ln of 2. 2 to the power x equals 21 divided by ln of 2. Now what? How do I bring that x down? What do I do? How do I bring this x down, guys? I don't have a calculator. We did it last year. No, we can't do square root. It doesn't have squared there. It's the x root. What'd you say? Do I do ln? Yes, I do ln. Guys, power rule for logarithms, guys. Side note, log x to the power b is b ln of x. So that's what we're using. If I want to solve for x, whatever you do to one side, you do to the other. You put ln and you put ln. And now I can just move that x to the front. So we move that x to the front. X ln of 2 equals ln of 21 over ln of 2. And yeah, you could do a property here, but I wouldn't. Leave it alone. All I got to do now to get x by itself is just what? Divide by, yeah, ln of 2. Divide by ln of 2, divide by ln of 2. X equals ln of 21 over ln of 2 over ln of 2. Nothing combines. There it is. That's your x coordinate. I guess if you wanted your y coordinate, you can plug that in there to get your y, but we're going to leave it as is. Okay, what rules do I got to know? Rules for logs. Let's put them here on the side, guys. You got to know your power rule. Power. Log b of a to the power c is equal to c log b of a. What else? Product. This is just from algebra, your algebra days. Log base b of ac is equal to log b of a plus log b of c. And then quotient log b of a over c, as long as c is not 0, or well, that's fine. Log base b of a minus log base b of c. It's actually the same rules as your exponent rules, your laws of exponents, if you think about it. That's because logs and exponential functions are inverses of each other. But you guys knew that, right? Okay. Like 2 to the power x and log base 2. Okay. That's pretty much it. I guess one more change. Should I even mention it? Okay, we won't mention it. Okay, I'm going to try to explain this as simple as I can. Do you know that ln and e are inverses of each other? Like, we know that definitively. Okay, we're going to derive the proof of ln of x. So this is the same thing as saying, let's see, e to the y equals x, right? Because if you wanted to cancel that ln, you would go e to the y equals e to the ln of x. And then this right here, that's just x. Okay. Now, I know we haven't gotten into implicit differentiation, but bear with me here. I think it'll make sense, I hope. I want to take the derivative of this guy, but I'm taking it with respect to x. But I notice that's a y. Whatever you do to one side, you do to the other. So the derivative of e to the y, so this is like chain rule here. So it's going to be itself. And then I got to take the derivative of a y. So can't I say the derivative of y is just dy dx? Right? Because every time we've been doing y, what's the derivative of y? We say dy dx, or we say y prime. Do you guys know what I mean? Okay, so there it is. So the derivative of e to the y with respect to x is itself times the derivative of the exponent. Well, that's a y. You can either say y prime or dy dx. Does that make sense? Equals, what's the derivative of x with respect to x? Yeah, say it loud and proud. 1. So everyone write this down, right? E to the y, dy dx equals 1. Are we okay with that? Okay. Does it make sense to you? Okay. What we're trying to do is find y prime. So I want to get dy dx by itself. So right now I have e to the y times dy dx. How do I get rid of that e to the y? How do I move it? It's a product right now. Yeah. Divide. So divide both sides. So I'm going to have dy dx equals 1. That's an equals. It just came out like a 2 there. Equals 1 over e to the y. We're so close. We're almost there, guys. I don't want this derivative in terms of y. But notice what we wrote earlier without the ddx on it. We said that e to the power y was equal to x. Did we not? Yeah, we said that. E to the power y is equal to x. So can I replace this e to the y there with an x? Yeah, it's called substitution. We can. So there it is. So I'm going to write it here. So what does that mean? So that means if I have ln of x, the derivative of ln of x is just 1 over x. So you can see it comes from somewhere. It didn't just magically appear. Luckily for you guys, all we got to do is just remember. What's the derivative of ln of x? 1 over x. Done. See? Cool or not cool? All right. Let's do the chain rule. So what's the derivative of ln of u? 1 over u times, what do you think I'm going to put on the side? Yeah, du dx. That's the chain rule part. Okay. Don't worry, guys. What's the difference between kids that are getting 5s and kids that are getting 3s and 4s? chain rule right here. This problem. Look at this. 72% of fives got this question right. And look at the big difference between fives and fours. 51% of fours, 36% of threes. Man, this question killed them. Only 40% of the total population got it right. So let's try this one out. Guys, if you get it wrong, it's okay. This is our first day. So you should not feel sad if you get it wrong. Give it a shot. Try your best with what we just learned right now. And see if you guys can get it right. It's chain rule. So take 2 minutes. Try it, Peanut. Try it. I believe in you. If you're close, keep going. I'm going to go ahead and start getting situated here. This says find ddx of f of ln of x. Wherever I have an x, I'm going to insert ln of x. So here's my function. F of ln of x equals ln of x, and then parentheses squared plus 2 ln of x. This is what I'm going to find a derivative of. So I'm going to write ddx. Giant parenthesis, ln of x squared plus 2 ln of x. You could also, this is not the only way, but this is, in my opinion, the easiest way. What do I do with that 2 here? Yeah, you're right. You're right, Cepeda. You bring it to the front. Leave the inside alone to the power 1. You can write the 1 if you want, but I prefer not to write it because it looks like a prime. Are we still okay? I'm not done yet. Chain rule times the derivative of the inside. You guys just told me what the derivative of ln of x is. What's the derivative of ln of x? 1 over x. So we're done with this term. Plus, this is a constant. It doesn't have a variable, so I don't have to worry about product rule. I can just write 2 and then take the derivative of ln of x. What's the derivative of ln of x? 1 over x. Notice that I wrote ddx on the outside, so this is not a linkage error. Some of you keep writing linkage errors all over the place. Let's just make it pretty. I'm going to write an equal sign. Write 2 ln of x over x plus 2 over x. Do I have the same common denominator? I do, so I can just add them up. 2 ln of x plus 2 all over x. Look for that. What answer is it? It looks like it's letter A. Did you get it right? That's cool. That's super cool. Cool or not cool, guys? All right. Here we go. A little bit of algebra 2. Before we even start the derivative, let's state the domain of f prime. The domain of f prime is the same as the domain of f. So hopefully everyone knows, I hope, and if it's okay if you don't, the ln of x looks like this, guys. Y equals ln of x. It looks like this, where it goes through the point 1, 0, and you have a vertical asymptote at x equals 0. The domain of this function is all values larger than 0. So that means this guy, the expression, the argument x minus 3, must be larger than 0. So my domain for this one is x greater than 3. So how does this function look in purple? That one looks like this. Here is 3. It's just a horizontal shift 3 to the right. Okay, here we go. The derivative. If f of x is equal to ln of x minus 3, then f prime of x is just equal to, you guys tell me. Well, guys, you guys tell me. We've been doing this for a while now. A few minutes. What is it? What is it? Hell yeah, it is. 1 over x minus 3. Done. That's your u. 1 over u times du dx. The derivative of x minus 3 is just 1. So there it is. That's it. Done. And the domain is x greater than 3. All right. Last one, and then we're clear, and then all we got to do is just practice, and then, yeah, those we already know. All right. Log base a of x can be written. This is called the change of base. It is also true that you can write it like this as well. So log base of a of x is equal to ln of x over ln of a. Now, remember that ln of a is a constant, guys. So we're going to write this as 1 over ln of a times ln of x. Why are we writing it like that? Because we know the derivative of ln of x. And then 1 over ln of a, that's just a constant. Also, side note, not to be outdone, log base a of x can also be written with log base b of x over log base b of a, where b is any number that you want to put. Don't put negatives. Stick with 1, 2, 3. Actually, don't put 1. 1's a bad one, because 1 to anything is 1. So 2, 3, 4, 5, 6, 7. Remember that logs and exponentials are inverses of each other. Okay. Are we still okay? Okay. All right, here we go. So I want the derivative of log base a of x. So I'm going to rewrite it, d dx. I'm going to rewrite it like this. 1 over ln of a times ln of x. Chav, why are you rewriting it like this? Because we know the derivative of ln of x. Cool or not cool? Okay. Equals. Chav, we're going to use product rule. No, this does not have an x in it. That's just a constant. Leave it alone. 1 over ln of a times, what's the derivative of ln of x? 1 over x. Done. Usually you put the x in the front. 1 over x ln of a. And then in the side, chain rule if you keep going. So here it is for chain rule. Don't worry, I'm slowing down. So what is it for chain rule? 1 over u ln of a times, and what do you think I'm going to put here on the side? Du dx. That's the chain rule part. Don't worry, we're going to practice. We're going to practice a lot. Cool or not cool? All right, look, we're going to practice. Here it is. Ready? We're just going to state the derivative. Well, I guess first let's state the domain before we even start. Go to the side. I need the expression or the argument, 3x plus 1 to be greater than 0. 3x greater than negative 1. X must be greater than a negative 1/3. That's the domain. Okay, here we go. I'm going to go slow, guys. I'm just using this rule right here. Does everyone see that rule? All right, here we go. F prime of x equals, and you got to use parentheses, 1 over, that 3x plus 1 is your u, parenthesis, 3x plus 1, close it. Am I done? No. What do I put next to it? ln of what? ln of 2. Am I done? No. Times the derivative of the inside. What is my inside? The 3x plus 1. What's the derivative of 3x plus 1? 3. Does everyone see what we did? So my final answer, f prime of x, is equal to 3 over, parenthesis, 3x plus 1, close it, ln of 2. And that's all you're doing over and over again, guys. Cool or not cool? Okay. These last ones will be simple for you guys. I have to put it in here because it's just the power rule again. Don't get confused. All right, we're done, guys. We're almost done. I have my variable, x, and I have a constant in the top. Use power rule. y prime equals, bring the square root of 2 down, x, subtract 1 from the power. Parentheses, square root of 2 minus 1, close parentheses, so no one gets confused. Leave it alone. That's a perfect derivative. Cool or not cool? Cool. Let's go to letter B. And then after this, we will just give you guys practice. Y prime equals, what did I do first? Chain rule. What did I do first? Move the pi down, pi. Leave the inside alone. 2 plus sine 3x close to the power pi minus 1. Am I done? No. What do I do next? The derivative of sine. What's the derivative of sine? Cosine. Keep the argument. 3x. Am I done now? No. What's the derivative of 3x? 3. If you want to rewrite all of it, y prime equals, let's see, 3 pi. I would probably put the cosine first because it's simple. Cosine 3x, giant parenthesis, 2 plus sine 3x, close, power pi minus 1. And I will put the pi minus 1 in parentheses so no one gets confused. And there it is. All right, let me do one more, see if you guys get tricked. What's the derivative of pi cubed? So say space. Yes, it's 0. Good. I'm glad no one told me 3 pi squared. Pi is a constant, guys. The derivative of pi cubed is 0. I guarantee you're going to see one like that on the exam. Promise. And I want to go to heaven, so I already said promise. You're going to see one that's going to say like pi cubed or pi something. All right. All you're doing is practice. Log into Delta, and all you're doing is derivative.